Determine whether the series is convergent or divergent. We have the summation n equals 1 to infinity n squared over the quantity of 2n plus 1 factorial. As soon as you see factorials, you should think of the ratio test. It works very well with factorials. And so we're going to do the limit as n goes to infinity of a sub n plus 1 over a sub n. We have a shortcut to that where we recognize the number of terms that we have and we give a fraction for each term. We substitute the n plus 1 terms in. So instead of n squared, we're going to have n plus 1 squared. Now be careful here. We have 2. Replace n by n plus 1. All of this then gets a factorial. And so what that is, by distributing the 2 across, that's 2n plus 2 plus 1 before the factorial. So we'll go ahead and call that 2n plus 3 factorial. With the other terms, the a sub n terms, we know that it's dividing by a sub n, which is a fraction, n squared over 2n plus 1 factorial. We are going to multiply by the reciprocal, so the associated terms would then be separated in the following manner, where we have n squared in the denominator, 2n plus 1 factorial in the numerator. Great. Now the way you deal with factorials is that if you have 7 factorial, say over 5 factorial, well, what you do is you write that 7 factorial as 7 times 6, and then of course we're going to have 5, 4, 3, 2, 1. We're just going to call it 5 factorial, and then the 5 factorial from the denominator, and we get cancellation. And so we basically peel off the 7, we peel off the 6, and then we have the 5 factorial to cancel. Same thing's going to happen here. We are going to peel off the 2n plus 3. One less than that is 2n plus 2. One less than that is what we have for the numerator, 2n plus 1. And we put the factorial on that guy. So that we cancel with all the rest of the terms that would be there, and we're left with these 2 terms in the denominator. How about n plus 1 squared over n squared? If you want, you can multiply n plus 1 quantity squared out. But what you quickly find is you have this polynomial in n squared, in n, which is quadratic, and then n squared in the denominator. The limit as n goes to infinity over a rational function like this, where the degree in the numerator equals the degree in the denominator, is the ratio of the coefficients. And it's for these reasons then that this guy goes to 1. So what we're looking at then is the limit as n goes to infinity, 1 over the product of 2n plus 3 times 2n plus 2 as n goes to infinity. Well, that's just going to go to 0. And so we have a limit that's 0. That's not a problem with the ratio test, because that's a number that is less than 1, and the ratio test gives convergence. And so we conclude, therefore, that the series that they gave us, I'll just generically call it a sub n, is convergent. by the ratio test. It's always good to say what test you're using, although it's already written there. Just write out your conclusion and restate the name of that test.